Welcome. I wanted to play around with fractals in ChatGPT. So here I am in the July 20 version of GPT-4, and I'm using it with the code interpreter plugin, which allows it to run Python code and draw diagrams, which is really useful. To start out with, let's have it list some of the things it knows about fractals. I didn't know all this for sure. This is interesting to me. Um, and when you're playing with it, if you want to dive in and ask it more about any one of these kinds of fractals, I'm sure it'll have a lot it could tell you about. In our case, I want to look at a few of them, and I'm most familiar with the Coke snowflake, so I want to start out there. The Coke snowflake is formed by starting with a triangle, and then each of the line segments in the triangle gets replaced by four smaller line segments that form kind of a jagged shape. And then as you go, making the snowflake more complicated, you just keep replacing line segments with that same shape scaled down to a smaller size. But I'll show you how that progression works. With these fractals, um, the simplest version of it is usually called the 0th order or the first order, which in this case is just the equilateral triangle. And then each time you apply the simple rule, whatever rule is used to form the fractal, then you move to the next order of the fractal. So you go from 0th order to first order to second order and so on. Each time it gets more complex as that simple rule gets applied to it, and you'll see what I mean here in a second, because now you'll see the first order Coke snowflake, which takes the 0th order, that triangle, and applies the rule to it to make it more complicated. Okay, so here it is, and you can see how it took the sides of the triangle and transformed them to make the first order snowflake. But it messed up. It missed one of the line segments at the top right. One of the cool things about ChatGPT is a lot of times if you just tell it that there's something wrong, it can find the mistake and fix it for you. So let's give that a try here. Sometimes it's a little bit slow, so I'm going to speed it up here so you don't have to wait. But there it is. And there's the correct first order Koch curve. Okay, so now it seems to be working. Let's just move on and get to see one of the more pretty ones, a fifth order Koch curve. And there it is. Beautiful, beautiful Koch curve. All right, nice. So yeah, let's take a quick look at the code. I haven't been showing that so far, but that's one of the great things here is you can see the code that ChatGPT wrote for you, and if you want, you can copy it to your own computer and run it, play around with it, try to understand how it works, um, or just make some tweaks to your liking. You can make tweaks to the code yourself and run it on your machine. Or another really cool thing here is you can just ask ChatGPT to make some changes for you. So let's give that a try here. Let's just make a simple change and turn the snowflake from green to blue. All right, just as one more example of the ability to just ask ChatGPT to make a change for you, let's experiment with changing the shape a little bit. Here I'm going to ask it to change how far those little V shapes go. You know, when each line is replaced by four other lines, there's a little V shape in the middle, and I'm asking it to make that V shape a little bit deeper, and that should have an impact on what the snowflake looks like. It may not be an improvement, but at least it'll show that you can just ask ChatGPT to make a change for you. And there it is. Yeah, definitely different. It's not bad. I'm not sure it's better, but it's kind of cool. And if you wanted to, you could look at the code to see exactly what change it made. But yeah, it's a neat little experiment. Yeah, let's take a quick look at the code. All right, so I think that's enough on the Koch curve. Let's move on and look at the Hilbert curve. So the Hilbert curve is a pretty interesting fractal because it's what's called a space filling curve, which means that as you move from the 0th order to 1st order to 2nd order, all the way up through the infinitieth order Hilbert curve, it, in theory, touches every point, all infinite number of points in a 2D square. And we won't take it that far, but you'll see how it starts to, how it covers the space evenly. But before we get that far, let's just start with the most basic Hilbert curve so you can see how it's formed. The first time it tried to do this, it really failed, so I had to get it to start over. But on the second try, it worked pretty well. So that basic shape is the first order Hilbert curve. It doesn't look like much right now, but it gets more interesting when we start moving up to higher order curves. So let's go ahead and give that a try. Ha! Okay, well, that is not correct. That is not a Hilbert curve. It's done something wrong, and I'm not even sure what it's done wrong. But again, we can just tell it that it messed it up and ask it to take a look and try to fix it. Um, you know, that way I don't have to go in and debug its code. In the past, I've seen Hilbert curves drawn using what's called an L system. And I'm not even really that familiar with an L system, so I'm not worried about the details of those, but I am just going to go ahead and suggest to it here that it might try to use one of those if it's not sure how else to get a good Hilbert curve drawn. Okay, and there it is. That's the second order Hilbert curve. It's several of those simple U shapes from the first order curve, but scaled down and rotated and connected to each other. So from here, we can look at higher order Hilbert curves. All right, cool. Yeah, starting to look more interesting. From here, let's just go on and go for a fifth order curve. All right, it's starting to look pretty good. And let's just go back and take a quick look at the code. Here's the code that drew that fifth order curve. But it's using some code it wrote up above, so let's take a quick look at that. That was for the third order curve, but that used this code. That is what actually draws any order curve. Doesn't take that much. All right, let's move on. In the list at the beginning, ChatGPT mentioned the Sierpinski triangle, and I've never really known much about that, but let's play around with it. Let's see what that looks like, and how it goes from low order versions of it to higher order versions of it. So let's just let ChatGPT do that for us. Here's the zeroth order Sierpinski triangle, just an equilateral triangle. And then let's see what happens when we go to first order. Okay, here we go. And that looks like a complete mess. So it got something wrong. As usual, let's just ask it to fix it. Okay, that's way better. So now that it seems to know what it's doing with the Sierpinski triangle, let's move on and have it draw a higher order version. Okay, another fractal I'm not really familiar with is the Barnsley fern that it put in its list at the beginning of this chat. So let's use ChatGPT to learn about those. One thing I learned here is that with the Barnsley fern, there really is no first order, second order, third order. The complexity of it just depends on how many points it plots. So it started out here with 1,000 points, and then to move on to more interesting, complex versions of it, it'll just add more points to the drawing, and you'll see that in a moment. Okay, that's probably enough for the fern. As one last fractal, let's take a look at the Mandelbrot set. It may be the most famous fractal, and I'm not sure how well ChatGPT is going to do with it here, but let's just see what happens. And there it is. Very cool. Well done, ChatGPT. Okay, so that's going to be it. This was my first video on ChatGPT and cool things you can do with it. Um, I'm going to put it out there. If you find it interesting, please let me know in the comments, just so I know whether or not I should keep making these. I'm kind of interested in making a whole series of them, but it would help to know if this is something anybody's interested in, and if you have any suggestions on how you can make it better, that would be great. Um, if I kept making them, I'd find a way to improve the quality as well, but I wasn't sure what to do for this first one. Okay, thanks a lot.